Hello, this is Math 1131 Calculus, and I'm having a look at this time at Chapter 4, Question 16. And this is an example of a problem involving rates of change. Again, as with many problems in maths, there are many ways of doing this problem. I'm going to show you the method that I find works quite nicely, and it often is the same method that one would use in many other similar kinds of problems. But there are other ways of doing the problem. So the problem is we start off with a ladder that's 5 metres long and we have it leaning against a brick wall. And the question says that we're given that the bottom of the ladder is being pulled out this way, so the ladder's moving downwards, and this point's moving out at a rate of 1 metre per second. And we want to find the change of area when the height up the wall of the ladder is 4. And so you see what I've done, I've put some axes in. I put in an axis, and then I can restate it as find the change of area when y is 4. And I'm going to call that distance along the x-axis x and up the y-axis y. So I need to now try and capture all the information in the problem here. So the fact that this point here is moving at 1 metre per second in that direction means that dx dt is equal to 1 metre per second. That's what that information means. What else can I capture out of this? Well, when y is 4, so if that's 4 units there, then I would have 4, and I've got 5, and of course you know the famous 3, 4, 5 triangle. So by Pythagoras, I know that x is 3 there, so I'll just note that there. Also, I can write down Pythagoras' theorem. So I'm just brainstorming this at the moment and writing down all the information I can. So that's by Pythagoras' theorem. And we're interested in the rate of change of the area. The rate of change of the area when y is 4. So I need to write down what the area, so the area of the triangle is, I'll call it A, and that will be 1/2 x times y. So what I'm doing so far is writing down all the bits of information out of the problem and writing down some formulae. So Pythagoras gives that, and that's area of a triangle. Now we want to find the rate of change of the area. That means I want to find dA dt. So we're trying to find dA dt. Remember, these x and y's, these are changing. As the ladder moves, this x is moving and this y is moving. So they're functions of t. And so when I go to differentiate this with respect to t, dA dt, I'm going to have to use the product rule. So note that carefully, product rule here. I'm going to copy the first, differentiate the second with respect to t, plus copy the second, differentiate the first with respect to t. That's what I'm trying to get my hands on, dA dt. When x is 3, y is 4, and we also know dx dt is 1, so the only thing we don't know at this point is this quantity. We don't know what that quantity is. By the way, you might be thinking another way of doing this would be to eliminate y from these two equations and then differentiate just with respect to t and so on. You can do that, that's fine. The method I want to show you is probably one that works slightly more generally, and so that's why I'm doing it this way. So we have to get our hands on this expression dy dt. So I'm going to look back and see how I might use the Pythagoras result up here in order to calculate dy dt. So I'm going to take the formula we got from Pythagoras' theorem, and I'm going to differentiate both sides with respect to t. So I take the derivative of x squared plus y squared with respect to t, and that has to equal the derivative with respect to t of 25. So I differentiate x squared, remembering x is a function of t, with respect to t. So I get 2x dx dt. Notice I'm using implicit differentiation. I differentiate the x squared becomes 2x and multiply by the derivative of the x, which is with respect to t, which I write as dx dt. We do the same with the y squared, becomes 2y dy dt. And I differentiate a constant, I get 0. Now, what we're looking to get our hands on is this expression, dy dt here. So I'm going to substitute everything in. So substitute all the variables that we know in. We know x is 3, so I get, and dx dt is 1, so I just get 6. And we know y is 4, so I get 8 dy dt, and that's got to equal 0. So dy dt is equal to minus 3/4. Minus 3/4, which is 6 over 8. We simplify that to minus 3/4. Now when you get a minus sign in the answer, you should be thinking, always in maths thinking, and you think back to the original problem, why would I get a minus there? What does it mean physically? Well, as x moves across here, the y values are getting smaller. So the dy dt is decreasing as the dx dt increases. And that explains why we're getting a minus sign here. Okay, finally, we substitute back to get dA dt back into our formula. So dA dt is going to be 1/2 times x times dy dt. So 1/2 times 3 times minus 3/4. We know our dy dt now, plus 1/2 times y, that's 2 times that gives me 2. So that gives me minus 9/8 plus 2, and 8 2s are 16, minus that gives me 7 over 8. So I get 7 over 8. Now 7 over 8 watt, we should give some units. That's going to be meters squared per second, because the area is measured in square meters. And so that gives me the rate of change of the area. So as this moves along, that's the rate of change of the area. Now, of course, there will be a limit on the size of this, because eventually, once x reaches 5, the ladder's flat on the ground. So this really, this scenario only makes sense for x between 0, when it's vertically this way, or when it's horizontal, when x is 5. But for any point in between, for this particular point, when y takes the value 4, the rate of change of the area is 7/8 meters squared per second.